Okay, so we're taking a look at number 6 in the year 2017. This is a really great problem because you're kind of given three different formats of a function and its derivative. One of them is pretty straightforward. It's just the table. The graph of h is given, it looks like, and then we're also given an equation. So somehow we're going to have to connect all of these. So this is really kind of cool. On number 6, it says, let f be the function defined by f of x equal cosine 2x plus e to the sine x. Let g be a differentiable function. The table above gives values of g and its derivative g prime at selected values of x. And then it says, let h be the function whose graph consisting of 5 line segments is shown in the figure above. In part A, it says, find the slope of the line tangent to the graph of f at x equals pi. So this just says the slope of the line tangent. When you're finding the slope of a tangent line, what we need to do is take a derivative and plug in the x value. Okay, so for part A, the function is cosine 2x plus e to the sine x. Okay, and we need to use x equals pi. So to take the derivative, the derivative of cosine is negative sine. The derivative of 2x is 2. Then we take the derivative of e to something, and e to the anything is just e to itself, right? And then multiply by the derivative of the exponent, the derivative of sine here being cosine. So it's a chain rule, all right? And then what we're going to do is we're going to plug in pi. So negative sine of 2 pi times 2 plus e to the sine pi times cosine of pi. The sine of 2 pi is 0, so this would be negative 0 times 2 plus e to the sine of pi. The sine of pi is also 0 times the cosine of pi, which is negative 1. Okay, if you don't remember that, maybe hopefully you can remember our chart and use that to help you evaluate these. Okay. 0 times anything is 0, so that goes away, and then I'm left with 1 times negative 1, which is just negative 1. Okay, so the derivative of the line tangent at pi is negative 1. Okay, so let's take a look at part B. Let k be the function defined by k of x equals h of f of x. Find k prime of pi. All right, so what we're going to do here is we're going to take the derivative of k, and k was h of f of x, and we're going to take the derivative of that and then plug in pi. So this derivative, take the derivative of the outside, but you keep the inside. This is a chain rule, so you've got different layers here. You've got to take the derivative of the outside, keep the inside, and then multiply by the derivative of the inside. And then what we'll do is we'll plug in pi. So k prime of pi equals h prime of f of pi times f prime of pi. F prime of pi we already found in part A, so that's kind of easy. This is just negative 1. And then I need to figure out what f of pi is. So I'm going to do that off to the side here. F of pi is cosine of 2 pi plus e to the sine pi. Cosine of 2 pi is 1 plus e to the sine pi. Sine of pi is 0, so e to the 0, 1 plus 1 is 2. So h prime of 2 times negative 1. Okay, so I need to go to the graph of h. And this is the graph of h, but I'm asked for h prime. So remember, a derivative is just a slope. So I need to figure out the slope at x equals 2. Okay? So at x equals 2 here, it looks like the slope is negative 1/3. That's just one line segment. Okay? The slope of that segment is negative 1/3. I'm going down 1/3. So at x equals 2, I went down 1/3 here. I went down 2/3 at x equals 2. Okay, but that's the x value. I don't need the x value or the y value. I need the slope. The slope of that segment is negative 1/3. I had it right the first time. So this is just negative 1/3 times negative 1, which is positive 1/3. So the derivative at pi is 1/3. Okay? So yeah, we were just looking for the slope. I was overthinking it, thinking of something else. Part C. Let m be the function defined by m of x equals g of negative 2x times h of x. Find the derivative at 2. So for part C. M is defined to be g of negative 2x times h of x, and then eventually I'm going to need to find m prime of 2. Okay, so let's go ahead and take the derivative of this. This is a product rule, so we're going to keep the first times the derivative of the second plus the second times the derivative of the first. So g prime of negative 2x, this is another chain rule. You keep the outside, or you take the derivative of the outside, keep the inside. Now take the derivative of the inside. Okay? And what we're going to do is we're going to plug in positive 2. So m prime of 2 equals g of negative 2 times 2 times h prime of 2 plus h of 2 times g prime of negative 2 times 2 times negative 2. All right, so let's kind of simplify some of these numbers a little bit before we get any further. So g of negative 4, h prime of 2 plus h of 2, g prime of negative 4, and then times negative 2. So g of negative 4, g is the chart. So g of negative 4 is just 5. So that one's not too bad. So this is 5 times h prime of 2. And h prime of 2 I found in the previous problem, and we said that was negative 1/3. H of 2, this is what I was talking about earlier, right? I'm going down by 1/3 each time, so this was 1/3. This was negative 1/3. So if I go down a third again, this would be negative 2/3. So h of 2 is negative 2/3. G prime of negative 4, g is in the chart. So g prime of negative 4 is negative 1 times negative 2. Okay, and then it's just a matter of simplifying this and cleaning it up. So negative 5/3, negative times a negative is going to be positive, but I still have that negative off to the side. So this would be negative 4/3, just multiplying straight across. Okay, and then adding them together, negative 9/3, which would just be negative 3. Okay? Okay. Part D. All right, so for part D, is there a number C in the closed interval negative 5 to negative 3 such that g prime of C equals negative 4? Justify your answer. So, because it's asking for, is there a number such that a derivative equals some value? In your minds, you should be thinking of MVT. It's trying to ask you, is there a place where the derivative equals a number? And that's just MVT, okay? So in order for us to apply MVT, we need to verify that g is both continuous and differentiable. Because g is differentiable, it is also continuous. So we're going to go ahead and state that. Okay, so because g is differentiable, it is also continuous. And we can apply MVT, okay? So for MVT, it says finding the average slope of the endpoints is equal to the derivative at some point. So what we're going to do is we're going to find the average slope of the endpoints, the average rate of the endpoints, okay? And this is for g. So this is on the interval from negative 5 to negative 3. So we're going to do g of negative 3 minus g of negative 5 over negative 3 minus negative 5. On the bottom, we'd get positive 2. G of negative 3, if I go up to my chart, G of negative 3 is 2, and G of negative 5 is 10. So I'd have 2 minus 10 on top, which is negative 8 divided by 2, which is negative 4. So yeah, because the average rate of my endpoints is equal to negative 4, which is what it's asking, according to MVT, because the average rate of my endpoints is equal to negative 4, that means somewhere in between negative 5 and negative 3, I would have a derivative that is equal to negative 4. Okay? So let's just write a conclusion kind of statement just to tie this all together. Therefore, by the MVT, there exists a C for C between negative 5 and negative 3 such that G prime of C is equal to negative 4. Okay? All right. Let me know if you have any questions.